Okay, so let's go through this the pop quiz on chapter 4 and 5. Okay, so the first question. Okay, so usually this kind of questions they will just provide you some context. For example, in this case, they already tell you that calcium chloride will dissolve in water to form aqueous solution. So actually from this paragraph itself, you can already kind of make a prediction of what kind of structure calcium chloride would have. So this knowing the structure allows you to make a better prediction on what kind of bonding will be involved. So in this case, since you know that it is soluble in aqueous solution, it implies that it's a giant ionic lattice structure. Okay, which means that the bonding will be ionic. So for chemical formula of calcium chloride, remember for all your ionic compounds, okay, in order to find the formula, you need to find out the chemical formula of the individual ions. So in this case, you have an ion of calcium, okay, as well as an ion of chlorine, which is called chloride now, okay. So for calcium, you know that it is group 2 period 4, so the formula electronic configuration of 2882. Chlorine is period 3 group 17, so it's 287. Okay, so just based on this, you'll be able to you should know that calcium will lose 2 of its valence electrons to form Ca2 plus. Okay, and chlorine will gain 1 valence electron to form Cl minus. So in this case, both of them will now achieve the electronic configuration of a noble gas. Okay, so remember Ca2 plus will be 288 and Cl minus will also be 288. Okay, so how do we write the formula? Remember, just bring down the number and you swap positions. Okay, this implies there's 1 Ca2 plus and 2 Cl minus ions in the formula. Okay, so in this case we can just combine them, CaCl2. Okay, remember the objective is always to balance out the charges. So in this case, you're trying to balance out the positive 2 charge from chlorine with the negative 1 charge from positive 2 charge from calcium and the negative 1 charge from chlorine. Okay, so the LCM is actually 2. Okay, so you make both of them become 2. You will need 1 Ca2 plus and 2 Cl minus. Okay, so same thing for this next question. Okay, take note that usually this kind of questions, the structure is always the same. Okay, when they will either ask you for the bonding or the structure. So you can just write the structure and then the bonding that follows. Okay, just give the just answer to whatever the question is asking. So if they're asking for you the bonding, just state ionic or covalent. Okay, if they are asking structure, you just say your GMS, your SMS, your macromolecule, your giant ionic lattice, or your giant metallic lattice. Okay, so in this case, this is state the type of bonding. Just tell me ionic bonding, you will get 1 mark. Okay, and what account for the electrical conductivity in the solid as well as the aqueous. So make sure you answer to both parts. And what does account mean? Account means you have to explain. It is not enough to state. Okay, so that's why a lot of you didn't get the marks. Okay, so in this case, remember that since it's a giant ionic lattice structure, it will be unable to conduct in the solid state. Okay, and you need to explain why. Okay, just merely stating that the ions are unable to move is not sufficient. Okay, in this case, you should say that either they vibrate about their fixed position in the giant ionic lattice structure or they are unable to move freely. So make the link to the structure itself. Okay, please do not mention about its electrons are unable to move, because in this case, the electrons are not actually participating. So just focus on whatever is involved. Okay, in this case, because there are ions present, just answer to the ions portion, that the ions are unable to move. Okay, so in the aqueous state, why are they now able? You can just state that they are now able to move freely. Okay, so in this case, there's no need to explain because the explanation was not taught to you. Okay, in the syllabus is not included. Okay, but you should know that in a solid state, they are vibrating about their fixed positions. Okay, so let's look at question 2 now. Okay, so question 2 asks you to draw the dot and cross diagram for the following okay, substances. Remember, before you even start drawing, make a mental note to yourself. Okay, you need to break down the question. Okay, so in this case, you have magnesium nitride. First, you need to determine whether it's a covalent or a ionic compound. Okay, if you from the start, if you already determine wrongly, you won't be able to get the answer. Okay, so in this case, you need to identify that magnesium is a metal, and nitride comes from nitrogen, okay, which is a non-metal. So you will have ionic bonding between metal and non-metal. Okay, so first thing first, go and determine the electronic configuration of both. So magnesium will be 282, okay, nitrogen will be 2.5. Okay, so you need to deduce that magnesium will form a Mg2 plus ion with 2.8 electronic configuration. Nitrogen will form a 2.8 configuration with formula N3 minus. Okay, so you can just write the two formula at the corner and determine what is the formula of the ionic compound. So do the same thing. Okay, swap the numbers. The formula will be Mg3N2, which means you will need 3 magnesium ions and 2 nitrogen ions or nitride ions. Okay, so you just draw the, in this case, because I only asked for valence electrons, if you drew the whole thing is also okay. But take note, for your cation ions, when they lose their valence electrons, the new valence shell will always be completely filled. Do not leave an empty shell. Okay, there will be 8, okay, or 2, depending on what kind of metal it is. Okay, when they lose their outermost electrons. Okay, in this case, magnesium will form a 2 plus ion. Okay, and and there will be 3 of it. Okay, so make sure you write these 3, and it should not be it should be in the middle. Okay, shouldn't be a subscript or a superscript. Okay, for the nitrogen side, remember you have to use a different set of symbols to represent the electrons of nitrogen. In this case, I chose to use circles to represent the electrons of nitrogen, as well as crosses for the electrons of magnesium. Okay, so remember, nitrogen should always have its original 5 valence electrons, which are shown here. Okay, original. Now it has gained 3, okay, from magnesium. That's why you have 3 crosses, and then it will have a 3 minus charge. However, you need to realize that magnesium there's not enough you will need to have 2 nitrogen ions to bond with 3 magnesium ions, such that the charges will cancel out. So you need to put in the 2 for the nitrogen. Okay, most of the time, the number of electrons gained here, okay, gained by the non-metal, okay, will not necessarily correspond to the number of electrons given out by the metal. That's why there's a need for you to balance out the charge. Okay, so how do you check whether your answer is correct? You need to use this method. Okay, remember, the formula of the ions and how the electrons are distributed are always the same. The only thing that changes will be the balancing portion, depending on what ions you are given. Okay, which group they belong to, how many electrons they gain or lose. Okay, next, for propanol, okay, you need to identify that all of the atoms are actually non-metal. Okay, CH and O are non-metals, which means it has to be covalent bonding. Which means I should not see square brackets at all, because there is no giving or gaining or losing of electrons. In this case, they are all being shared. Okay, so remember, for covalent bonding, I always recommend starting with the structural formula, instead of just blindly trying to distribute the electrons such that everyone gets a fully filled valence shell. Okay, in this case, they already broke it down for you. They have given you a structural formula, which means that if you just follow this order, you will ensure that all the electrons, all the atoms will have a fully filled valence shell. So in this case, you start with C3H7, which means, okay, there will be 7 hydrogens around 3 carbons. Okay, the question may or may not give you in this format. I can actually also give you C3H8 O, which is the molecular formula of this propanol. Okay? And if I'm giving you the molecular formula, there's no way you'll be able to deduce the arrangement. So this is what we call the structural formula, which if I give you, you should be able to get the structure at least. Okay, by just following the order. Okay, remember when you do your covalent bonding or your dot and cross for covalent substances, always keep in mind the valency of each atom, which means how many bonds they can form. Okay, carbon has a valency of 4, hydrogen has a valency of 1, and oxygen has a valency of 2. So at all times, remember to ensure that all these are satisfied. Okay, so for example, I check this carbon. It has 1, 2, 3, 4 bonds. It is satisfied. Each hydrogen has 1 bond. Okay, satisfied. Middle carbon has 4 bonds. Satisfied. Now, this third carbon has only 3 bonds at the moment. So I need to give it 1 more bond. So I will bond it to oxygen because I'm just following the order. Okay, and then finally there is 1 hydrogen bonded to the oxygen. Okay, is this the end? Okay, of course not, because they want a dot and cross and they did not ask for a structural formula. Okay, and remember for oxygen, and in fact, all non-group 14 and 17 elements, which means your group 14, your group 15 and 16 elements, they will have unbonded electrons. Okay, so remember, oxygen will have 2 pairs of unbonded electrons because they only form 2 bonds. Okay, likewise, those in group 15 like nitrogen will have 3 unbonded, 1 pair of unbonded electrons. Okay, so now you just need to translate this into here. Okay, how do you do it? You can just use the same symbol to represent electrons of the same element. In this case, for each carbon, I'm using crosses. For each hydrogen, I'm using dots. From each oxygen, I'm using a circle, open circle. Okay? So it does not matter, it does not really matter what kind of symbols you use as long as I'm able to deduce, okay, that which electrons belong to which atom. And you get roughly this. Okay? Next, question 3. Okay, they ask you why and how. Okay, how, why, and how. Remember, you have to answer to both. The melting points of diamond and phosphorus trichloride are different. Okay, remember, first thing you see when you see this kind of question, go and identify the structure. Okay, diamond is a GMS. Okay, phosphorus trichloride. Okay, this one I expected you to deduce from the name what kind of compound it is. Okay, remember, trichloride means it is a PCl3. Okay, phosphorus trichloride, 3-chlorine. Okay. Okay, usually the questions, if they give you some unknown, some foreign compound, they should provide you with more context. For example, telling you what kind of boiling point, melting point it has, so that you'll be able to better deduce the structure, and then from the structure you can deduce the bonding. Okay, but sometimes some compounds are simple enough that you should be able to deduce their bonding. Okay. For example, those majority of metal and non-metals, they will form ionic bonds. Okay, so you are expected to know that they will be ionic in nature. In this case, okay, you are expected to know that it will be covalent in nature. Okay, however, don't worry so much. The question in the exam should provide you more information if the covalent compound is kind of foreign to you. Okay, so same thing, this kind of question, they ask you for melting points are different. You need to tell me the structure first. Okay, so please answer the question part by part. That means focus on the diamond part, then you focus on phosphorus. Do not do comparison by comparison and give me like many paragraphs. Okay, so in this case, you tell me diamond has a giant molecular structure. Okay, and you need to explain what this structure consists of. Okay, so in this case, you have strong covalent bonds between the carbon atoms. And you need to tell me the energy required. So remember, first one is always structure. And then from the structure, you must lead to the energy. And third one is conclusion. So in this case, this format is mainly for your high or low boiling and melting point. Okay, So the structure involves stating the structure and also what the structure entails. Okay, what is inside what is special about the structure, what kind of bonds there are. Okay, and are there weak or strong forces or bonds. Okay, so you will tell me a large amount of energy is required to overcome these strong covalent bonds, therefore diamond has a high melting point. That is the conclusion. Okay, repeat the same process for phosphorus trichloride, PCl3, simple molecular structure with weak intermolecular forces of attraction between molecules. There is no need to state that there are strong covalent bonds between the phosphorus and chlorine atoms within the molecule. There is no need, because when you are melting it, you are not breaking these strong covalent bonds. Okay, you are only breaking the weak intermolecular forces of attraction between the molecules. So please just focus on what is important. What bonds are you trying to break? Okay, bonds of force. Okay, in this case it is a force that you're not breaking the bond. Okay, and lastly you tell me that small amount of energy is required to overcome these weak intermolecular forces, therefore low melting point. That is it. You will get the 3 marks if you mention the structure and energy required for each, and then concluding that diamond has a high melting point and phosphorus trichloride has a low melting point. That is sufficient. Okay, moving on to the last question. Okay, so this kind of question is very, very common. Okay, that they will not provide you with much information except maybe the boiling point, melting point, as well as the solubility at room temperature, in water at room temperature, or in organic solvents at room temperature. Okay, so you have to be able to deduce or make a prediction on the structures based on what information you are provided. Okay, so even before looking at the questions themselves, I would like you to make a prediction about the structure based on the information provided. Okay, let's look at substance A. Okay, boiling point 1090, usually we'll just classify this as high. Okay, there is no black and hard and fast rule about what temperature actually constitutes high, boiling melting point, or low. Okay, it's more of a comparative kind of by comparison to the others. Okay, in this case, I can see that 1000, I have 1000, 4008, 1004, and 180. The 180 is definitely low compared to the rest. Okay, next, A is a white silvery solid. So when you see silverish or shiny solids, you should tend to think that they are metal. So of course I do not know if it's a metal yet. I'll just put a question mark first. Okay. So lastly, they tell me insoluble in water at room temperature and pressure. Okay, does that satisfy the giant metallic lattice? Actually, yes. So in this case, I will put giant metallic lattice. Okay, of course I do not know for sure yet, but based on just initial kind of prediction, okay, it's unlikely to be any others for now. Okay, next, let's look at B. Definitely high boiling melting point. Okay, high boiling point, and they tell you that it's a colorless, transparent, crystalline solid. Okay, at this stage, you probably will not be able to tell based on the appearance what kind of structure or bonding there will be. Okay, so maybe we'll just skip over this first and focus on the solubility. Okay, remember it's insoluble in water at room temperature and pressure, which means it cannot be, okay, it cannot be a giant ionic. Okay, it could be a simple molecular, but remember the boiling point is so high. So let's do some process of it cannot be your SMS because of the high boiling point. It cannot be your giant ionic. Here I'll just short form as GI. Okay, what is left? It's either macromolecule, okay, giant metallic lattice, or your giant covalent. Okay, giant metallic possible, but if let's say A was a giant metallic, okay, B is unlikely to be giant metallic as well. Okay, so what else? Macromolecule definitely not, because macromolecules do not have such high boiling melting points. Okay, and the last, and that's it, right? So it's most likely your GMS. I'll put a question mark first because we actually do not know for sure. Next, let's look at C. Okay, boiling point, remember, since you said 1090 is high, 1420 is also high. Okay, so they tell you that it is soluble in water at room temperature and pressure. Most likely it should be giant ionic. Okay? Why not everything else? Because look at the solubility. Okay? Your giant metallic, your GMS, will and your SMS will be insoluble in water at room temperature and pressure. Okay? So this has to be your giant ionic. In fact, they already told you it's crystalline solid, which means it consists of crystals. Okay? The full name for your giant ionic lattice structure is actually giant ionic crystal lattice structure. Okay? So lastly, let's look at D. Low boiling melting point, definitely SMS. Okay, this one is the one that I'll know for sure because only your SMS structure has low boiling melting point. Okay? Double check with the solubility. It is soluble in water at room temperature. Okay, this one is the question mark. Because what you understand about SMS is they are insoluble in water at room temperature and pressure. Okay, so let's just go off the melting point, boiling point first. Because melting and boiling point is the most indicative of the structure. Okay, so let's try to answer the question now. If you realize that since based on our annotations, it's very easy to do the questions now. Okay, which one has giant ionic lattice structure? Definitely C. We already established that. Okay, could be B as well, but oh sorry, cannot be B at all. Okay, could be A as well, but based on the fact that A is silvery, unlikely to be A. So answer is C. Okay, next. They're asking you which substances are able to conduct electricity in the liquid state. Remember, keyword here is liquid. Okay, so which substances do you know that we are able to conduct electricity in liquid state? Metals for sure. Your giant metallic lattice structure as well as your ionic. Okay, remember these two will be able to conduct electricity in the liquid state. Okay, so based on that, since it's metal and ionic, I will know it's A and C for sure. Okay, however, okay, why is D also accepted? So I actually accepted any two of A, C, D. So if you gave me AC, you gave me AD, you gave me CD, I would have given you the mark. Okay, why is D accepted? Because D is actually, okay, D is actually aluminium chloride. Okay, the formula is AlCl3. Okay, aluminium chloride is actually very special because even though it is consists of a metal, aluminium and a non-metal chlorine, it actually has covalent character, which means that the bonds are more covalent than ionic. Okay, you need to understand that ionic and covalent bonds are just opposite ends of the same spectrum in terms of how strong how strongly the electrons are belonging to in each atom. Okay, so ionic is just one side and covalent is one side. Okay, since because of the nature of the atoms, okay, actually your aluminium and chlorine atoms will tend to share electrons more than transfer electrons. Okay, therefore giving rise to this weird or I'll say exception that this non-metal and metal actually form a covalent bond. Okay, and note that the solubility is also very special. It is soluble at room temperature and pressure. Okay, so what actually happens for aluminum chloride is even though it's covalent in nature, if I do dissolve it in water, it will just form back the ions Al3 plus and Cl minus. Since it forms back these ions, it will be able to conduct electricity in liquid state. Okay, so once I melt it, okay, your aluminum chloride the ions will be able to move and conduct electricity. Okay, so just take note that this is an exception. Okay, the question should provide you more information if they want you to give this as an answer. That's why I accepted any two. Even if you didn't give me D, I would want to see A and C and I will still give you the mark. Okay? Question C. Okay, they say they want electrostatic forces of attraction. So, okay, electrostatic usually we're referring to ionic. Okay? Or metallic. Why are there electrostatic forces of attraction in metallic compounds metallic elements or mixtures? Is because of the electrostatic forces of attraction between your C of D localized electrons as well as your metal cations. Okay, metal K ions will be positive, C of the localized electrons negative. Therefore, they will have strong electrostatic forces of attraction between them. Okay, likewise for your ionic between plus and minus ions. Okay, positive and negative ions. Okay, so in this case, same thing. You can say A and C, and I'll give you the 2 marks. You can mention D as well, and I'll give you the 1 mark for any 2 mentioned. Okay, because the nature of D is very special. Okay, they ask you kind electrostatic forces of attraction because it has both covalent and ionic character. Okay, you are not expected to know this for D, but it's just FYI. Okay, to give you the complete picture. Okay, last but not least, the question D. This is the type of question that they will provide you with a lot of information if they want you to provide an answer that is not to to what you have learned in the syllabus. Okay, so they tell you that aluminium chloride has a low boiling point. Please highlight this. A lot of you seem to overlook this point, low boiling point, and they tell you it's soluble in organic solvent, both of which are uncharacteristics for compounds formed from metal and non-metal. What does that mean? It means that even though it is formed from a metal and non-metal, okay, so it will have been it should have a giant ionic lattice structure which will have high boiling point and is insoluble in organic solvents. This aluminum chloride is completely opposite to that. Okay, so they ask you to suggest which substance could be aluminum chloride, or actually all you have to do was identify which of the 4 substances would have low boiling point as well as is soluble in organic solvent. Okay, the solubility here you will not know because it's not provided. Okay, however, based from the low boiling point, you should be able to figure out that D is your aluminum chloride already. And they already mentioned uncharacteristics for compounds formed from a metal and non-metal, which means that this substance itself doesn't follow the conventional way of predicting the structure. So based on A, B, C, D, only D was really a question mark because of the having low boiling point but being soluble in water at room temperature and pressure. Okay, so answer would be D. You have to make the most educated guess based on the information that you have. Okay, so that's how you would get the answer for D.